So Alhamdulillah, in yesterday's lecture, we have completed the first part of topic 1, of topic 2, which is the electronic configuration, will be the last subtopic involving quantum number and whatnot. Okay, so that will be the first part. So the second part of topic 2 is the periodicity. Okay, so like what I have briefed you in yesterday's lecture, periodicity is a pattern. Okay, is a pattern on how the elements behave in the periodic table. So in the periodic table, the elements are arranged in period, okay, rows, and also group. So how do they behave in period and also in group? Okay, so we have four characteristics of elements in the periodic table that we will discuss in this second part of topic 2. Okay, one is the atomic size. So what happened to the size of the elements of the atoms of the elements when across the period and also down the group. Okay, and we also want to know what happened to the ionization energy of the elements, again across the period, down the group, and electron affinity, last but not least, the electronegativity of the elements. Okay, so we want to know all of these characteristics for elements in the periodic table. So that is what we call periodicity. Okay, in simpler explanation. So that is periodicity. So we have 2 learning objectives for this subtopic. Okay, make sure that you can cross off this 2 learning objectives once you have completed the subtopic. Okay, all right. So periodicity. Okay, periodicity is a regular repeating patterns related to the atom valence electron that occur among elements. Okay, it is a regular repeating pattern that relates to the atom's valence electron, okay, that occur among elements, and it organizes the elements effectively, especially those who are newly discovered. So these patterns are responsible in defining the elements in a group with similar physical and chemical properties. Okay, so they were arranged based on similar physical and chemical properties. That's why we have groups, okay, and also rows. So basically for groups, okay, those elements in the same group have the same or similar physical and chemical properties. Okay, so the periodic table is organized into horizontal rows called period and the vertical column called groups. The period number corresponds to the principal energy level, which is N, okay, of the valence electrons. And the group number corresponds to the number of valence electrons. Okay, all right. So this is how our beloved periodic table looks like. So we have the N, okay, so N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, 5, and so on. Okay, and we also have, that will be the row lah, the period. Okay, and we also have the group going down. So 1, group 2, group 13, 14, 15, 16, and until 18. Okay, all right. All right, so we're going to start with atomic radii first. Okay, so what is atomic radii? Radii is the plural for radius. Singularly, it is radius. Okay, atomic radius of an element is the distance between atomic nuclei in a sample and divide that distance in half. Okay, so we have atomic form of atomic form of a species, and we also have covalent, okay, covalent radius. So covalent radius is more on the molecular form, okay, and then we also have ionic radius. Ionic radius is more on between cation dengan anion. Okay, all right. So the atomic radius is half of the experimental determined distance between the nuclei of nearest neighbors in the solid. So assume this is the nucleus for the first atom. Okay, and this is the nucleus for the second atom. So the distance between these two, okay, between these two nucleus divided by 2, that would be the radius. Okay, divided by 2, this is the radius of the atom. Okay, all right. Same goes to covalent. For covalent radius, it is determines between the nuclei of nearest neighbors in the molecule. Okay, and for the ionic radius, it's the distance between the nuclei of neighboring cation and ions. For example, we have sodium chloride, calcium chloride, and whatnot. Okay. Okay, so that is in terms of definition of atomic radius. Okay. In yesterday's lecture, I have highlighted other than the 4 behaviors of elements in the periodic table. Okay, before we could go for that, okay, we should know what are the main factors that affect all of those. Yang apa main factors that affect the atomic radii, for example. Okay, and that also affect the ionization energy, electronegativity, and electron affinity. Okay, so there are two main factors that determines the size, the ionization energy, electron affinity, and the electronegativity. So we are going to discuss that first, then only we would go for the trend. Okay, the trend for the atomic radii and whatnot. Okay, so first factor is known as effective nuclear charge. Okay, nuclear means nucleus. Okay, charge means the charge of the nucleus. So we know that in the nucleus, okay, so assume this is a nucleus, we have proton and neutron. Okay, right. So the proton is positively charged, whereas neutron is neutral. Okay, so if that means the nucleus charge is positively charged. Okay, because it consists of proton, and proton has positive charge. So the nuclear charge is positively charged. Okay, the nucleus charge. But when we have effective at the front of the term, the name of the nuclear charge here, so it means that the charge felt, okay, the charge or the attraction felt by the valence electron. Remember, it's all about valence electron, the attraction between nucleus and the valence electron. Because these valence electrons, they come and go, betul tak? Dia keluar, dia masuk. Okay, so this will determine the properties ataupun the behavior of the atoms, of the atoms of that particular elements. Okay, so nuclear charge means the nucleus charge, whereas the effective nuclear charge is the charge experienced by the electron, the valence electron. Okay, to be specific, it should be valence electron. So we could represent effective nuclear charge as ZF. Okay, Z is a proton number, remember? So this is also represent the nucleus charge. Okay, so effective is the charge experienced by the valence electron. Okay, all right. So in proper definition, effective nuclear charge is the total amount of attraction, okay, or positive charge experienced by an electron, especially the valence electrons towards the nucleus. Okay, so kalau senang nak imagine, we have nucleus. Nucleus is like the mother. Okay, so nucleus is positively charged, and we also have electrons. Okay, electrons outside of the nucleus. So what held the electrons in place? Apa yang menyebabkan that electron dia stay in place? Because of the attraction with the nucleus. If not, dia akan keluar daripada region yang sepatutnya. Okay, so that's why we have nucleus to hold the electron in place. It's like the mother. Okay, so electron is like the children dekat situ. The further the farther it is from the the nucleus, that means the attraction is lesser, betul tak? Kurang kasih sayang. Okay, it is lesser. That means bila attraction kurang, the size, boleh imagine in terms of the size, okay, it will become larger. Okay, so that is in saya boleh kata in short lah, to give you an idea how effective nuclear charge affect the radius or the size of the atoms. Okay, all right. So Z effective can be approximated. It can be approximated. This is not actual. Okay, it can be approximated by using this equation. So Z effective is equal to, okay, Z is the proton number or the atomic number, okay, minus the core electron. So why do we need to minus the core electron? Because remember, Z effective measures the attraction between the nucleus and the valence electron. So kita kena minus lah the core electron tu. Okay, we have to minus the core electron. Then only we can know atau we can measure the charge felt by the valence electron. For example, okay, let's say sodium. Okay, sodium. The proton number for sodium is 11. Okay, so how do we calculate the Z effective for sodium? So Z for sodium is 11 minus the core electron. So how do we determine the core electron? Okay, so the core electron should be the total electron minus, so in order to find out the core electron, okay, it should be total electron in the atom minus the valence electron. Then you get your core electron. Okay, so total electron for sodium atom will be 11, okay, because we are talking about atom, not ions, minus the valence electron for sodium, okay. So the valence electron for sodium, so sodium come from group 1, right? So by right, it should have one electron, one valence electron. So it is equal to 10. Okay, so there are 10 electrons in sodium. So 11 minus 10 will be positive 1. Okay, alright. So apa yang kita boleh conclude from this value? Okay, out of 11 positive charge, yang the charge for the nucleus, so out of 11, only positive 1 is felt by the valence electron. Okay, remember they kena share with other electrons as well. Of course 11 tu when we divide to we consider all other electrons, okay, out of 11 only positive 1 is felt by the valence electron. Okay, so that is how you approximate the Z effective. You use this formula to approximate. Okay, ni sebenarnya macam ni, approximate. Okay, alright. So we could kalau nak senang ingat dan cepat, okay, Z effective is actually the same as the group number. Okay, so sodium come from group 1, right? So the Z effective is positive 1. Okay, like beryllium, for example, beryllium come from group 2. So we would know that Z effective is equal to, for beryllium, Z effective, the attraction felt by the valence electron is equal to positive 2. Okay, for chlorine, for example, okay, the Z effective for chlorine is positive 7. Itu nak cepat, okay, nak ingat cepat. Tapi, how do you get positive 7? This is how you calculate the Z effective. Okay, ini nak bantu you cepat tahu, maksudnya cepat boleh boleh conclude, okay, to summarize and whatnot. Okay, tapi you should know that to calculate Z effective, how do you get positive 7, positive 2, positive 3, positive 4 is by right through this equation. Okay, right. So across the period, atomic radius decreases due to increasing in Z effective. Okay, so increasing attraction between the nucleus and valence electron causing atomic size to decrease. Okay, So let's look at example that we have here. So lithium, beryllium, boron. So these three elements come from the same period, which is period 2, n is equal to 2. So that's why they're across the period. Okay, all right. So try to calculate the Z effective. Okay, so you can calculate the Z effective. So Z effective for lithium is positive 1. Using the formula just now, okay, Z effective for beryllium is positive 2. Z effective for boron is positive. Boron come from group 13, right? So it has 3 valence electron. The group number is group 13, so positive 3 lah. Okay, kan cepat kan? Tapi kalau sepatutnya you kena guna the Z effective formula just now. Okay, alright. So what can we conclude from here? Okay, as you can see across the period from lithium to boron, the Z effective increases. Okay, what does that represent? Apa maksud ni? Kalau increasing kenapa? Maksudnya the Z effective represent the attraction between nucleus and valence electron. So the higher the Z effective, the larger the Z effective. That means the attraction experienced by the nucleus and the valence electron, experienced by the valence electron, okay, is stronger. Stronger lah sebab electron is negatively charged. Nucleus is positively charged kan. So their opposite charge attracts one another. Okay, so the more positive ataupun the larger the nuclear charge or the Z effective, by right, the attraction between the nucleus and the valence electron is stronger. Bila stronger, the valence electrons are pulled inward, tertarik ke dalam because of the strong attraction tadi. Okay, and then what will happen to the size? The size become smaller lah. Okay, dia logik saja. You bila you dapat dia punya logik, you will automatically remember. Senang. Okay, dia bukan something yang you kena hafal. Dapatkan the logic first, then only it helps you to remember better. Okay, to memorize better. Okay, alright. So across the period, the size becomes smaller due to ZF. Okay, alright. Okay, so that is one of the factor that is Z effective, the attraction between the nucleus and the valence electrons. Okay, it's all about the attraction between nucleus and valence electrons. Senang cerita, okay, factors that cause the variation in terms of characteristic atomic radii, ionization energy, electron affinity, and electronegativity, okay, is caused by the attraction felt by the valence electron. It's all about that. Okay, next up we have shielding effect. Shielding means it's like perisai ataupun sometimes it is known as screening effect. Okay, screening effect. So what is shielding or screening effect? Shielding is like perisai, like I said just now kan. Shielding ni dia prevent, okay, it prevents the attraction from the nucleus to the valence electron. Dia mengurangkan the attraction. So that is what we call shielding. Shielding means perisai, mengganggu the attraction between the nucleus and the valence electron. Okay, so shielding effects describe the attraction between an electron and the nucleus in any atom that exhibit more than one electron shell. So shielding effect is present in atom that has more than one electron. So obviously in the periodic table, okay, all of the atoms, all of the elements have more than one electron except for hydrogen. Hydrogen has only one electron. So the rest are all having more than one electron. Okay, so boleh kata semuanya ada screening effect. All the elements, all the atoms in the periodic table has this screening effect. Okay, so what is screening effect, guys? It's the inner electron shield or repel the valence electron away from the nucleus. So this shielding effect is due to the repulsion between electron and electron. Okay, because we know that electrons and electron, they have same ataupun similar charge kan. So same charge ataupun similar charge will repel each other. Okay, they cannot get closer to one another because they will repel. Okay, so that means the repulsion is higher there. So can you imagine, okay, in an atom that has more electron in it, that has more than one electron in it, that means the higher the electron, we could imagine that the screening effect or the shielding effect would be higher. Okay, boleh imagine tak dalam nukleus tu, yang ibu dia tu, the mother tu, nak kena pegang all the electrons because of the opposite charge. Okay, dia attracts. But at the same time, the electron in the atom itself tu pun dia repel, dia menolak-nolak. Okay, so this repulsion can also cause the size to be varies. Okay, boleh berubah. Okay, alright. So the inner electron shield or repel the valence electron away from the nucleus. Remember, it's all about the attraction between nucleus and the valence electron. So, meaning that if you have more inner electron in the atoms, that means the shielding effect will be higher lah. Okay? So repulsive forces between electrons in different sublevels are stronger than that between electrons in the same sublevel. So imagine, so this is the nucleus kan, and then these are all the electrons. Okay, assume that this is n is equal to 1 and this is n is equal to 2, right? Okay, so between this n is equal to 2, so n is equal to 2, we have the valence electron in n is equal to 2. Okay, alright, so electron and electron, they repel each other. So we have this electron, these two electron in the same sublevel. Okay, and we also have this electron, so they repel, of course they will repel. Okay, and we also have the valence electron and the inner electron. Okay, so these two of course will repel. Okay, so this repulsion is this is in different sublevel, this is in the same sublevel. So which one has higher repulsion, has a greater repulsion? So the one that has greater repulsion will be in different, the repulsion from different sublevel. Okay, compared to in the same sublevel. Sebab sebelum nak sampai the valence electron, the nucleus punya attraction tu kena attract the inner electron first. So dekat situ dah ada shielding dekat situ, shielding layer 1. Okay, and then imagine if you have more n, that means you have more inner electron. By right, you should have the atom will have higher shielding effect. Okay, so the more electron shells there are, the greater the shielding effect experienced by the outermost electron. Okay. So that is what we call shielding effect, guys. Too. As long as there are more than 2 electrons, there will be shielding effect. It's just that they're significant or insignificant. Okay, all right. So those two are the main factors that affect the atomic radii. Okay, because we are talking about atomic radii now, kan? Okay, remember, we have to explain the trend in terms of across the period and down the group. Okay, alright, so in terms of across the period, the size changes, okay? So the size become smaller ataupun decrease across the period, okay? So atomic radii of the representative element. Representative element is the main element. Representative and main, they are actually the same thing. Okay, so we are going to cover only for the main element. For the periodicity, we are going to cover for the main element because transition element, macam biasa, it is special. There are its own explanation there. But we are not going to cover it. We are not going to cover that in our syllabus. Okay, right. So across the period, the size decreases. Kenapa the size decreases? Because there is a steady increase in the Z effective, okay, across the period, which cause the valence electron to be held more strongly by the nucleus. Maybe you can add in lah dekat sini. Across the period, Z effective increases. Okay, bila Z effective increases, the attraction, you kena highlight the attraction. Okay, so please add in this info into the first point that we have here. Okay, across the period, Z effective increases. And then what happened to the attraction? The attraction between the nucleus and the valence electron becomes stronger. Okay, so the attraction becomes stronger. And the electrons are pulled inward, dia tertarik ke dalam and cause the size to become smaller. Okay, alright. That is for what we call across the period. Okay, how about down the group, guys? Okay, so for down the group, we cannot explain, bukan cannot lah. There is not much of a difference if we are highlighting the Z effective. Bila going down the group, the Z effective is not that effective. Bukan, it's not significant lah. Bila kita cerita down the group, Z effective is significant if we go across the period. Okay, tapi bila down the group, Z effective is not significant. Tapi apa yang significant? Shielding effect will be significant. Sebab apa? Logically speaking, when we go down the group, okay, the number of N increases. Betul tak? N is equal to 1, 2, 3 and so on. Bila the number of N increases, the principal quantum number increases, the N increases, okay, when that increases, the number of electron increases as well. Betul tak? Okay, it increases. So the shielding effect will also increase. So this shielding effect will shield ataupun will screen the attraction between the nucleus and the valence electrons. So the attraction become weaker, lemah lah sebab ada banyak elektron dekat dalam tu. So this shielding effect cause the size to become larger. Okay, that is in terms of down the group. Sebab kita tak boleh mention kita tak boleh highlight Z effective sangat. Bukan tak boleh highlight. It's not that significant lah senang cerita. Because imagine if you are talking about the elements in the same group. The Z effective kan sama. Positive 1, positive 1, positive 1. For group 1 for example. Group 1 Okay, so sodium, potassium and so on. They are all having the same Z effective. So that's why kita tak boleh highlightkan Z effective saja. Dia tak significant. Okay, so bila going down the group, you have to mention in terms of increase in shielding effect. Okay. Yep, this is the general trends. Okay, decreases due to what? Due to Z effective. Kena mention in terms of Z effective. And then down the group, you kena mention in terms of shielding effect. Okay, right. Okay, this is in terms of graph. Okay, this is in terms of graph. Macam mana nak baca graph ni? Madam tak faham lah macam mana nak baca graph ni. Okay, alright. So ini kita ada period 1, period 2 and so on. Okay, so let's just look at period 2 lah, senang cerita. Okay, so period 2, we're gonna start with lithium. Lithium come from group 1, right? So going down, so lithium, and then we have beryllium and so on until neon. So these are all elements that come from the same N, which is N is equal to 2. Okay, as you can see, the trend of the atomic size is decreasing. This is across the period. Okay, they're across the period. They have the same period. Nampak tak? The size decreasing. This is for N is equal to 2. Same goes to N is equal to 3. Nampak tak? Dia decreasing. Okay, this is due to increase in Z effective. Okay, alright. So we have period 4. So period 4, as you can see, dia increasing. Dekat sini kita dah start ada transition element. So just ignore this transition element. Okay, because as you can see, dia punya what we call that, the size. Okay, there is not much of a different. Okay, dia sikit je beza dia. Dia ada reason because kenapa kat situ cuma kita tak cover. Alright, and same goes to period 5 and so on. So as you can see, dia decreasing. The size decreases. Okay, alright. How about down the group? Down the group, kita kena tengok across the period ni lah. So as you can see ni lithium, sodium, potassium, rubidium and cesium. So the size become larger. The size increases. Betul tak? Okay, this is in terms of, you kena mention in terms of shielding effect. Okay, in terms of shielding effect. Right. Okay, write the electronic configuration of oxygen and fluorine. Choose the atom that is larger in size and explain your choice. Okay, so far, are you doing okay? Are there any questions so far? Do you have any question?
Okay.
Okay.
Okay ke?
Okay.
Okay, faham
Okay.
So basically, as of now, we have two factors. Okay, this kita still in atomic radii. Okay, so we haven't go for ionization energy. Belum lagi, ini baru atomic radii. So for atomic radii, we have two factors. Okay, basically these two factors applies for all the characteristic later on. For all the ionization energy, electron affinity and electronegativity. So you should know these two factors. Okay, so and also make sure that you are able to determine, okay, for across the period, you should be highlighting the Z effective. Down the group, okay, you should be highlighting the shielding effect. The increase in N cause the shielding effect to be higher and so on. Okay, right. Write the electronic configuration of oxygen and fluorine. Choose the atom that is larger in size and explain your choice. Okay, so we have 3 questions here. So first, electronic configuration, and then you have to choose which one is larger, and then you have to explain your choice. Okay, so to write the electronic configuration, you should have the Z, the value of Z for oxygen and fluorine. Okay, and oxygen and fluorine. For the atom, we are talking about atom now. Maksudnya without the loss or ataupun gain of electron. So ni atom. So we need the value of Z because the number of electron will be the same as the number of proton for atom. Okay, so Z for oxygen will be 8, Z for fluorine is 9. Refer your periodic table. Okay, alright. So now how do we write the electronic configuration for oxygen? So let's start with oxygen. Kita buat sama-sama Kita buat sama-sama. Okay, oxygen, we have 8 electron, right? So 1s2, 2s2, 2p. This is 4 already, so we need another 4. Okay, so this is oxygen's electron configuration. Please check, okay, so total up 4 plus 2 plus 2 is equal to 18, and then 4 plus 2 is equal to 6. That means the oxygen come from group 16 because this is where the valence electrons are located. Okay, and this is the core electron. So banyak sangat information, banyak sangat hint that you could use to check your electron configuration. Okay, that make sure you punya electron configuration is correct. Jangan buat shock sendiri Gunakan this hint to help you to make sure that your answer is correct. Okay, so fluorine 1s2, 2s2, 2p, 5. Okay, 5 plus 2 plus 2 is equal to 9. And fluorine come from group 17. 5 plus 2 is equal to 7. So there are 7 valence electron in fluorine. And fluorine come from group 17. Okay, the highest N, remember the highest N. So this is the core electron for fluorine. Okay, all right, so moving on, which one, okay guys, which one is larger? Is it oxygen or fluorine?
Fluorine.
Oxygen.
Oxygen.
Cuba dengar fluorine.
Oxygen.
Okay, all right, answer the question. Which one is larger? I'm not talking about which one is smaller. Which one is larger? Okay, if you are talking about which one is smaller, then the answer should be fluorine. If which one is larger, then it should be oxygen lah. Okay, alright, so oxygen, so we are done with this one, dah cover, we have the answer already. Choose the atom that is larger, so the answer would be oxygen is larger than atom. Fluorine atom lah. So let's specify that, okay? Fluorine atom. Oxygen atom is larger than the fluorine atom. Okay, we are done with this one. Okay, explain your choice. Okay, how do we explain, guys? What's the reason the oxygen is larger than fluorine? So what need to be highlighted in the answer, guys?
Z effective.
Yes. Okay, you need to highlight the Z effective. Kenapa you highlight the Z effective, not the shielding effect? Based on what? Macam mana you tahu the Z?
Across the period.
Period.
Yes. Okay, how do you know that they both come from the same period?
Principal quantum number.
Is equal to?
Principal quantum number. Yang
Sorry,
nombor
yeah.
2.
N is equal to 2.
Okay, so based on principal quantum number, but you have to specify, okay, both of them are located at n is equal to 2, okay, based on the highest value of n. Okay, and that is why we know that this is across the period sebenarnya. Okay, so when this is across the period, you have to highlight the Z effective. You can highlight the shielding effect, but it's not significant sebab shielding effect memang akan ada. Tapi across the period, the nuclear charge increases. Itu yang paling dominant lah dekat situ. The power of the nucleus is now increases. So itu lebih dominant. Okay, so you have to mention in terms of Z effective. So you have to calculate. Okay, the Z effective for oxygen is positive 6. Okay, and fluorine has positive 7. Okay, so Z effective of oxygen is lesser ataupun smaller. Okay, smaller Z effective yang sama waktu dengan dia lah ya. Tak semestinya exactly the same macam ni, tapi you have to have that point lah. Z effective of oxygen is lesser than the Z effective of fluorine. Okay, that means attraction felt, so the attraction felt by the valence electron for oxygen, okay, is lesser, therefore the size become larger. Okay, yang sama waktu dengannya lah statement itu. Mesti you have to talk about Z effective and then the attraction. Mesti relate these two, Z effective and attraction, and last but not least will be the size. Okay, alright. Ya, ini kena highlight the Z effective lah. Jangan cakap Z effective increases. Tak nak, you kena highlight what will be the Z effective for both atoms. Okay, alright. Okay, so please complete this checkpoint. Okay, we will discuss this later next week. Okay, so I'm going to proceed for the ionic radii. Okay, ionic radii. So we are done with atomic radii, atomic radius. Okay, next will be ionic radii. So we know that ionic radii stand for ions lah. Okay, so we have atom. When the atom gains electron, they become anion. When the atoms lose its electron, they become, ataupun lost its electron, they become cation. Okay, as simple as that. Yes. Okay, dia jadi cation dengan anion. Okay, so for cation, the valence electrons are removed lah. Okay, remember, to remove electron, it need to be removed from the outermost shell. Tak boleh lah tiba-tiba nak remove from the inner shell kan. Remember, it's ada attraction yang kuat. Dekat, the more closer the electron is with the nucleus, okay, to the nucleus, the stronger the attraction. So boleh imagine tak yang N sama dengan 1 tu, the attraction will be very, stronger lah, very strong. Okay, so you senang-senang je nak remove the inner electron, it's not as simple as that. Okay, that's why we go for the outermost and then kita buang satu sampailah later. Okay, tapi kita tak, normally dia tak akan buang semua elektron lah. But that is how you nak imagine the step by step process in order to remove the electron. Okay, so the valence electrons are removed. For the anion, okay, the atom accepts electrons. So the new electrons are added into the valence shell. Okay, logically speaking lah, okay, cation dengan anion. So which one will have larger in size, guys? Is it cation or anion?
No.
Sorry? Which one will have larger in size? Is it anion or cation?
Anion.
Anion. Faham tak soalan saya betul-betul which one will have larger in size? Cation or anion? So the answer would be anion. Okay? Sebab apa? Logik dia tambah elektron. Okay? The electron is added into the atom. So when more electron is added into the atom, that means apa yang akan increase kat situ? Apa yang akan increase kat situ? Guys, when more electron is added into the... Sorry?
Size or shell.
Before we go for the size, when electron...
Repulsion effect.
Yes, repulsion is also known as...
Shielding.
Yes. Okay? So logically speaking, bila dia jadi anion, that means electron is gained. Betul tak? Electron dimasukkan dekat dalam atom tu. So they become an ion. So more electrons in the system. More electron means more repulsion. More repulsion means more shielding effect. So what will happen to the size? The size become larger lah. Okay? Senang aja dia punya logik dia. And cation on the other hand, dia remove electron. Bila you remove electron, that means less repulsion. Less repulsion, less shielding effect. What happened to the attraction between nucleus and the valence electron? You become stronger. So bila dia stronger, the size become smaller lah. Okay, so as simple as that. That's why dapatkan dia punya logik saja. The rest you akan pandai lah main sendiri dekat situ. Okay. So that is the idea of the size of atomic and as the size of ionic radii. We have cation dengan anion. So the rest of the electron for the cation, the rest of the electron will be attracted more strongly and closer to the nucleus. So by right, cations are smaller than their parent atom. Parent means original atom. Okay, so by right, cation is smaller than its parent ataupun original atom. Sebab original atom ada extra electron. When it become cation, okay, the electron has been removed. So that's why the size become smaller. Okay, so the cation valence electrons experience a larger Z effective than the valence electron of its atom and shrinking the ion even more. Okay, sebenarnya you boleh imagine tak in terms of Z effective, the cation, the Z effective for cation will change. Kenapa dia change? You imagine Alright, so this is the nucleus. Dia buang valence electron kan? Okay, sabar madam, lukis dulu. Okay, so we have one electron here. Katalah there is one valence electron. So of course we have other inner electron in the atom. Okay, so when this one electron has been removed keluar dekat situ, so there's no valence electron kan? The outermost shell is therefore empty with electron. There's no electron dekat situ. Okay, so how do we calculate the Z effective for this cation? Macam mana nak calculate? So next, the coming the next shell will become the valence shell. Nampak tak? Sebab elektron yang asal tadi dah keluar. So the next shell will become the outermost shell. So electrons dekat situ will become the outermost electron ataupun the valence electron, the new valence electron. So how do you calculate the Z effective now? So you kena calculate based on the new ions lah, the new system tadi tu. So kena consider, so the number of inner electron has decreased Kenapa decrease? Because tadi tu yang jadi inert electron tadi, they become the valence pula sebab dah kena buang elektron tadi kan. So when you calculate for Z minus S, the Z effective, okay, for ions, for cation lah to be specific, okay. So you have to consider the S is now less than the original atom. Sebab S tadi inner electron, part of the inner electron now has to become the valence. Okay, right. So that is what we call cation, and repulsion between the added electron and the existing electron in the valence shell causes the valence electron being pushed further away from the nucleus. Okay, and ions are larger than their parent atom. So that is the summary, okay, in terms of size of cation dengan anion. Okay, alright. So kita boleh conclude that the more electron, okay, kat sini lagi the more electron has been removed, that means the smaller the size become. Okay, and same goes to anion. The more electron you add into the atoms, okay, the larger the size become. Okay, due to shielding effect just now. Okay. Alright, so next term we have isoelectronic, guys. Isomer, isothermal, anything that involve iso, it means sama ataupun similar or same. Okay, electronic come from the word electron. Okay, so electron lah. So isoelectronic, that means species having the same number of electrons. Okay, so iso means same or similar, electronic means electrons, same electrons, the same number of electrons. Species having the same number of electrons. Okay, and hence the same ground state electron configuration. When they have the same number of electron, of course, they will have the same electron configuration. Okay, it is called ground state electron configuration without the excitation. So that's why dia ada nama ground state dekat depan tu. Okay, maksudnya there's no excitation takes place. Kita tak belajar sampai excitation tu. Okay, so we can call it as ground state electron configuration. So isoelectronic means when the species, the chemical species having the same number of electrons. For example, sodium plus, okay, when sodium become cation, it is now has the same electron number as neon when dia jadi cation. Okay, same goes to aluminium 3+ when it remove 3 of its electron, it is now having the same number of electron with neon. Okay, same goes to fluoride ion, F-. This is an ion, right? So 1 electron has been added into fluorine atom becoming F-. So instead of 2p5, kalau fluorine atom, it is 2p5. When they become an ion, it become 2p6. So these ions is now having the same electronic configuration as neon. Same goes to O2- and N3-. Okay, so these are all called isoelectronic. They are all isoelectronic with one another. Okay, so they are also isoelectronic with neon. Tapi sesama dia ni pun isoelectronic. Okay, having the same number of electron. Alright, okay, so sama by using the same understanding that we have for cation and anion earlier. Okay, we apply for isoelectronic. Okay, we can apply for isoelectronic even though they have the same electron number, they have the same electron number, but in terms of size, they differ. Dia tak sama. Okay, right. Take for example, if we are talking about cation, okay, so sodium plus, magnesium 2+, aluminium 3+, these three are isoelectronic with one another. Tak percaya, pergi check dia punya number of electron for the ions. Okay, sodium 10, magnesium 2+ also 10, aluminium 3+, after the 3 electron has been removed, they become 10. Okay, so they are isoelectronic. However, in terms of the size, they differ. Kenapa? Based on what? Satu, okay, maybe you can tambah dekat situ the more electron they remove by right, the smaller the size. Because less shielding effect. Dia tak ada dekat sini maybe you can tambah here. Okay, the more electron has been removed, that means the less shielding effect, the smaller the size. That is one. And then in terms of Z effective, this is in the same period kan, maksudnya they all have the same period because semua ni dia punya electronic configuration dia sama. Maksudnya bila dia jadi ion, they have the same number, the same principal quantum number, the highest principal quantum number. Okay, alright. So in terms of size, kita boleh highlight the Z effective. Okay, dah lah across the period we know that the Z effective increases kan. Lepas tu buang pula. So by right aluminium atom has higher Z effective. Now bila dia jadi aluminium 3+, it has even higher Z effective. The value of Z effective. Okay? Alright. So same goes to N3 minus, O2 minus dengan F minus. Okay. So N3 minus they accept, this ion accept more electron compared to O2 minus and F minus. So the more it accept electron, the larger the size. Okay? In terms of Z effective, N lower kan? Positive 5, this is positive 6, positive 7. Dah lah dia punya Z effective is lower. Accept pula 3 more electron. That means the shielding effect becomes larger. Okay? Alright, so we can conclude if you are to compare the cation and anion, so this is how the arrangement of the ions, the size of the ions. So the largest will be N3 minus followed by O2 minus, and then lastly we have the smallest would be the aluminium 3+. Okay, right. So we have checkpoint. So please complete the checkpoint. Okay, we will discuss during our lecture next week. Okay, I think that's all for today's lecture, guys. Any questions so far? All right, ada